So this video is my lecture for Chapter 2 and Chapter 3. And I want to go through and discuss some of the concepts that are covered in the two chapters, as well as give you a demo, a demonstration of some of the features actually in action. So if you take a look at Chapter 2, it's all about configuring failover clustering. And if you've looked at some of the other videos that I've posted, in the Chapter 1 we looked at a network load balancing cluster, which is primarily used to load balance requests from the internet from different areas over several different nodes or several different servers so that one machine isn't doing all the work. In a failover cluster, it's very similar. We typically set up what is called an active-active configuration, where you have multiple machines, nodes, all doing different things. But the benefit of the failover cluster is that if one of the nodes fails, the cluster is able to handle moving the load of that machine that failed over to another machine, where it just picks up and continues on processing and doing the request. So one of the key things when you set up a failover cluster is to ensure that you have adequate resources on all of your nodes or servers, so that if you do lose one node or one server does fail because of a hardware issue or some other reason, that the other machines have enough capacity to be able to pick up the load. So that's an important part. They do talk about on page 17 the whole idea of an active-passive cluster, where one machine is active. They're both on the network. They're both running, but only one is doing all the work. Typically what we like to do is set up a more of an active-active type of cluster. In order for a machine to qualify for a cluster, it has to be running typically the Windows Server 2012 R2 operating system. At least that's what we're using in this class. You can use older versions. A cluster that we set up can support in Windows 2012 R2 about 64 nodes. We do want to make sure, and it's quite critical, that the hardware that we're going to be using is pretty much the same. If you take a look on page 19, they talk about some of the failover clustering requirements. You should go through these different bullet items, but essentially you want to have the same or similar hardware for each of the nodes on the cluster. I will tell you that's probably one of the weaker areas of the Microsoft solution. If you look at clustering from a VMware approach, they're less critical about it being on the same hardware, where Microsoft really wants to see the same BIOS, the same vendor, manufacturer, the same motherboard, the same disk space, the same amount of memory, the same service packs, the same everything. They want to see that stuff configured on all the nodes pretty much the same. And initially if you're setting up your cluster, you might be able to do that. The issue becomes what happens if a node fails and now it's 3 years since you bought the original machine and now you have to get something up and running. How are you going to handle that? So that is something that you want to take in consideration. But you'll notice in here that they do mention you should think of identical systems are best, therefore you should consider the following items, and they list them on 19. As part of setting up a cluster, it's best to use it with different types of applications where it works with a single set of data. And databases work well for clustering. One of the areas where we probably won't use a cluster is Active Directory. And so my question to you would be why? Think about it for a second. Why would we not want to use a cluster with Active Directory? And what I mean by that is a domain controller. Why would I not want to set up one of my nodes as an Active Directory domain controller in the cluster? And the answer for that is really because Active Directory has its own replication mechanism. So I can have multiple Active Directory domain controllers out there in a network, and they will all replicate themselves using what is it? AD. My mind just went blank. It's not File Replication Service anymore. It's not FRS, but it's built into AD. And so there is a replication engine that is used. So when we look at this chapter, we do need to be concerned about the clustering requirements. You'll also notice on page 18 they talk about the fact that we need to be concerned about a network, some sort of common network. And here's the thing, you're really going to have about 3 separate networks. If you think about it, you need one for the nodes to be able to communicate. Something where they can determine, hey, have we lost one of our nodes? So in other words, in a 2 or 3 node cluster, are all the nodes communicating with each other? Secondly, we need potentially a network that our clients can access, so that they can access the resources that are available in the cluster. And we'll do that by creating basically a virtual cluster name and an IP address. And then the third third network is really for storage. The whole idea behind a failover clustering is that you typically want to have, and it's not a requirement, but you want to have the files that or the services that you're going to cluster available on shared storage, so that if one machine goes down, it becomes available to the others. Think about it. If you had your machine up and running, let's say it's machine A, and it has its own disk drive, and you stored all your stuff on it, and you've got that machine A set up in a cluster, and machine A suffers a hardware failure where it suddenly is no longer available, how do the files that are on A get onto one of the other nodes? Where if it's on shared storage where both machines can access it, it just makes it so much easier. So when it comes to networking, we'll have private and public networks that are made available for the purpose of the machines to communicate, for clients or other computers to be able to access, as well for our storage. Okay. And they do mention cluster storage in here, a system that is shared between cluster nodes and usually connects using fiber channel or iSCSI. And we're not going to talk about fiber channel and iSCSI in great detail in this chapter, but when we get to, I believe it's chapter 6, I'm going to have a lecture in there where I'm actually going to show you some iSCSI and fiber channel configurations and some information that you'll be able to use to help you understand that. Okay, so the bottom of 19 says private networks, public networks, and public and private networks. And they talk about the use of a heartbeat so that the nodes can communicate with each other. So those are pretty important things. Now, to get this thing up and running, if you look at the book, and things are never really this easy, but they make it sound like you just install the clustering feature, and you then basically create and validate a cluster, and you're all set. Well, that's true, but there's usually a few more things that you have to do. And if we take a look at the last bullet item on 19, underneath the requirements, they say each node must be in the same Active Directory domain. So for starters, you really should have an Active Directory domain set up. So if you're thinking, well, how does this, what I'm showing you today, relate to project number 1 that you're going to have to do? You don't have a domain. So you're going to have to create one and set one up. And you're going to have to set up a user that in that domain that the cluster can work with. Okay, so I'll just give you that information for starters. So we need to install the role, or it's not the role, excuse me, the feature for failover clustering. Okay, that's going to be a key part of this. And then we have to configure and create the cluster, and they talk about different ways of using storage. And if you notice that where they say configuring cluster storage in the bottom of 22, they talk about shared serial attached SCSI, internet, iSCSI, fiber channel, and fiber channel over Ethernet. You can do a SMB share as well. And this is discussed a little bit in one of the other chapters where we talk about using just a bunch of disks and creating an SMB share. And again, it's they mentioned this, I believe, in chapter 3 or 4, and we'll take a look at that. And that's really the key behind what you're going to do with your project number 1. 23, configuring and optimizing clustered shared volumes. So the whole idea is if I have this shared disk space, then I want to make that available to all of my nodes in the cluster so they all can communicate with it. Now, think about this for a second. What are the possible problems we run into if 2 machines try to access the same hard drive? So for example, 2 computers accessing directly the same C drive on a machine. They're both referencing and using the same hard drive as drive C. Can it be done? Yes. However, we run into issues where one machine locks files and possibly records that another machine is trying to access. And so it's not usually recommended, and I'll talk more about this later, that when you do have shared storage, that the nodes access the same disk, because one might be trying to lock records or lock files that another machine is working with, or might try to access files and records that another machine is working with, where we can get potential corruption. So you'll hear me talk about this again, but essentially, if I have shared storage and I have two machines, let's say it's host 1 and host 2, host 1 has its own disk, host 2 has its own disk. And it may be shared storage out there from the standpoint of they both have access to different disk drives, but you never let host 1 and host 2 talk to the same disk, bring the same disk online. And unless you configure what they call is a clustered shared volume. So if you take a look at the area on page 23, they say traditionally a single node, meaning a PC or a host, controls a LUN on shared storage. A LUN is like a disk drive, okay? And again, when I get into chapter 6, I'll go through the whole idea of LUNs, but it's a logical unit number. It says, however, starting with Windows 2008, Windows can use a clustered shared volume which allows multiple nodes to share a single LUN concurrently. Instead of taking control of the entire LUN, a node takes control of an individual file. Without a clustered shared volume, a clustered role can fail over quickly. With a clustered shared volume, a clustered role can fail over quickly from one node to another without requiring a change in drive ownership or without dismounting and remounting a volume. Yeah, so typically what would have to happen is if I have two machines, host 1 and host 2, and they each want to access the same disk, you can't do it at the same time. You'd have to, if host 1 is using it and host 2 needs it, you'd have to take that disk online and then go over to host 2 and make it online. So both machines can see the disk, it's just only one of them can access it at a given time. So they talk about using clustered shared volume here. And the idea is that it essentially, and I'll show you in this demo, it ends up being a folder that both machines access where the data is stored. And we'll get a chance to see this, okay? So, and then they talk about adding a volume to the clustered shared, to the CSV. So here's the thing. The way we create and manage and do everything with failover clustering is through this software that gets installed called Failover Clustering Manager. And I'll show it to you here in just a second. And that's where the main console or tool that we use for everything that we want to do with failover clustering. All right, and so I realize I'm hitting you up with quite a bit of information up front. Hopefully the demo will make things a little easier and you'll get an idea. And I just want to quickly go through some of these concepts that are in the book so you have an idea of, what does this mean? What is it? And then I'll show you in the demo kind of where we see some of this. Page 26, configuring quorum. So we have to be concerned about what is a quorum. If you've ever been part of a group or a meeting, let me see if I can give you an example. A board of trustees or a board of directors wants to get together and they want to vote on some issues. So let's say, I'll give you a recent issue that's happened in Traverse City area lately. It's about the idea of having tall buildings in the downtown district. Let's say that right now the building height is restricted to 6 stories and they want to allow buildings taller than that. Well, because of ordinances, that's something that has to get voted on by a city commission. And so the city commission wants to have a vote to discuss this and get it approved. And in order to approve that, they have to have a quorum. That means that there has to be at least a majority of the trustees that sit on the city council, or the council members, have to be present to vote. If there's 6 people on the council and only 2 are there, well, then that's not a majority. They don't have a quorum. So they actually can't put the idea of having, allowing buildings taller than 6 stories. They can't take a vote on it because they don't have enough voting members. So the idea is what is considered a quorum and how many people have to be present in order for a quorum to be valid. We use the same language or concepts when we talk about failover clustering. So a quorum is used with a failover cluster to determine the number of failures that the cluster can sustain. So without having the whole cluster fail. So if I have 3 computers, 3 nodes, how many of those machines can I lose and still have my cluster available to handle resources? What if I only have 2 nodes in my cluster? How many machines can I lose, and how does it know if I truly have lost a node? So there's a number of pieces that go in here. And they talk about talk about this. If a quorum, the majority of the votes, is not reached, the cluster will stop running. Each voting element contains a copy of the cluster configuration, and the cluster service works to keep all copies synchronized. So if you have 2 nodes, 3 nodes, and when I say that I mean machines, running in a cluster, they each keep a copy of the configuration. They give you some examples in here, and if you are planning on the certification exam, you need to go through these and have a good understanding of what they mean by the quorum, the different options for quorums. But if you take a look on 26, and I don't want to read this all to you, you guys can read through this, but they talk about if a cluster has 5 nodes and it needs 3 nodes to keep it running, have a majority, then they can have 2 nodes fail. So when you configure the quorum, there are 4 basic quorum configurations. Node majority, recommended for clusters with an odd number of nodes. It can sustain failures of half the nodes rounding up -1. So if I have 3 nodes in my cluster, okay, I can then use a node majority. It means I can support a failure of half the clusters. Okay, so half of 3 is 1.5. Round it up to 2 and then subtract 1. I can lose 1 node in a 3-node cluster. If I lose 2, it doesn't think that the that the cluster is still valid, that it's up and running. Node and disk majority, recommended for clusters with an even number of nodes. It can sustain failures of half the nodes rounding up if the disk witness remains online. So what is this idea of a disk witness? Basically, you can take and configure a disk drive, it could be just a partition or a volume, as a disk witness. And both of the machines then, both nodes, look to see if that witness disk is there. And they use that witness disk to determine then if the cluster has failed. So in other words, in a 2-node cluster, I can actually lose one of the machines, but as long as I can still see the witness disk, the cluster is still valid. So otherwise, if you think about it, if I only had 2 nodes and I lost one of them, well, then I'm the only one running. And so I may not have majority, and as a result, then the cluster would go down. So the witness disk provides an added level for us to be able to validate and say, yeah, the cluster's okay. Even though I've lost half the nodes or one of them, I'm still okay. Node and file share majority, used for clusters with special configuration. Instead of using a disk witness, it uses a file share witness. And no majority, disk only, allows the cluster to function as long as one node is available and the disk are online. However, this configuration is not recommended because the disk might be a single point of failure. Yeah, so if you think about it, with shared storage, it means all of my machines have access to the same disk. But what kind of redundancy or fault tolerance has been put in place to make sure that if that shared storage suddenly goes down, that there's a backup someplace? So we really need to look at redundancy there. So what they're saying is, unless you've got some sort of redundancy built into your shared disks, the idea of node majority probably isn't a good thing. Okay, so that's a lot of Chapter 2. They talk about configuring storage spaces. Hopefully you had some of that in the class, Server 1 class, where you were learning about the 7410 exam. Storage spaces is a way of taking disk space from different types of devices and drives and configuring a storage space and making that available to a machine. So we can use storage spaces. In fact, you will find that for Project 1, if not Project 2, you will be defining and setting up some storage spaces. Okay. So they go through this. Another cool thing in here is configuring clusters without network names. So I said earlier you need Active Directory. Well, you can set up an Active Directory detached cluster, which allows you to deploy a cluster without any dependencies in AD for the name. Because remember, when we create a cluster, you're going to be asked to not only give it an IP address, but give it a name that can be stored in DNS. So when you create an Active Directory detached cluster, you register the cluster network names within the network names of the clustered roles to your DNS server without creating objects in AD. Okay, so it's just another way of doing this. Where might I do this aspect? Maybe I've got two physical machines that I'm setting up and I want to cluster them, but I'm not going to have Active Directory. They both have access. They're workgroup machines. They have access to some form of shared storage, but I don't want to have an AD environment. I do have DNS set up, but I don't have AD. Might be a reason for doing that. Okay. If you look page 33, lots of PowerShell commands. You can manage, do everything you need to from PowerShell. Now I'm going to use the GUI in our demo, and essentially what I'm going to show you is what I've set up and give you some ideas of some things. But you can manage this whole thing with PowerShell. I would encourage you, look over these commands, kind of look through them, these commandlets, get familiar with some of them. You could see them on the exam, and I'm not saying you have to know every single one of them, because if you look at page 33 through 35, you got 2 pages of them. But there's some important ones here. How to start the cluster, how to stop the cluster. Okay, those would probably be ones that I would want to take a look at. Things like that. Bottom of 35, implementing cluster-aware updating. So this brings up an interesting thing. So obviously, once I get my cluster up and running, and I've got, let's say, 2 machines running Windows 2012 R2, they're joined to a cluster, and all of a sudden, there's Windows updates. And remember, we said there was a requirement to try to keep them all updated on the same OS, same version, same patch level, same everything. So what about when updates are needed? So what's the best way to handle this? Well, one of the cool features in 2012 is something called cluster aware updating. And what it allows you to do is take the nodes in your cluster and, using cluster aware updating, schedule it so that essentially what it's going to do is download and install the updates on host 1. And of course, what's it usually have to do after it finishes installing updates? Reboot, right? So what it will do is it will then drain all the resources off from that cluster, move them to the best node possible, which in our case, for our example, would be host 2. And then it reboots that machine. When it comes back up, it then, as part of cluster aware updating, downloads and it brings the resources essentially back over to that host, downloads and installs the updates on host 2, and of course it needs to then be rebooted, and it takes all the resources that were on host 2, brings them over to host 1, reboots host 2, and then puts the resources back. So it's a process by which we can do Windows updates, and this will happen across all nodes in the cluster. So if you had 10 different servers connected to this cluster and you need to do Windows updates on all of them, essentially what it does is it takes those resources, drains them, moves them over essentially to another host or another node, installs the updates, reboots that machine, brings it back up, connects it back to the cluster, pulls the resources back over, and then goes on to the next machine. And I'll show you a little bit of this. I'll show you how we have that set up. Okay. So they talk about using cluster aware updating, and it's something you actually have to install. It's another essentially feature that gets done. They discuss upgrading the cluster. This has always been kind of a hassle. What do I do if all of a sudden Windows 2016 comes out, which it should be out here in just a few weeks? My understanding is it's coming out in September, and I need to upgrade all my cluster servers, my nodes, to 2016. Well, if you've ever worked with any of this stuff, you can't just suddenly make them all run 2016 overnight. Usually there's some planning. So how do I go about upgrading part of my cluster to 2016, and what do I do about the remaining hosts that are still running 2012? Prior versions to 2008, this didn't work very well. You pretty much had to upgrade all the machines in the cluster at the same time. And that could create a lot of potential issues. And they even tell you in 38, if you have a cluster running 2008 or 2008 R2, and you want to upgrade to 2012 or 2012 R2, upgrading the cluster is more difficult if you want little or no downtime. Therefore, in these situations, you need to plan your upgrade. Okay. When you migrate from an existing cluster to a new, you create the new cluster containing 2 nodes. You then migrate from the existing cluster to the new one. So in that situation, what they're saying is create a brand new cluster with a couple new computers in it, migrate the cluster from 2008 to 2012. Okay, essentially. So they have a migrate cluster wizard that you can use to go through. So take a look at that. Backing up and restoring cluster configuration. So where is cluster configuration stored? Well, it's stored in what's called system state. So it's very important that your hosts, your nodes, you back up the system state of those machines. If you're not familiar with the system state of a computer contains critical files and information, and depending upon what's running on that machine, it could be everything. Well, it does include the registry, but it could be things such as Active Directory. If it's a domain controller, the Active Directory database is stored in the system state. So you want to make sure you back up the system state. The idea of just backing up your hard drive, your C drive, is not enough. You can back up the C drive all day long, but if you don't back up a specific component of the files that are stored on that C drive called the system state, you will run into problems. Okay, so we want to make sure we do that. So that's essentially chapter 2. It's preparing you and showing you how to install the cluster. Okay, I'm going to do that here in a second with our demo. All right, so I want to talk about chapter 3 as well, because with chapter 3 they're talking about managing failover clustering roles. And so here's the thing. If you take a look at the bottom of 47, when we want to use clustering, you can cluster a lot of stuff. I can use DFS, and that was what I was trying to remember earlier, is the replication engine that Active Directory uses, distributed file system. I don't know why my mind went blank. DHCP, distributed transaction coordinator, file server role, generic applications, iSCSI target servers, internet storage servers. These are different roles that we can set up. Notice one of them, virtual machines. And that's what I'm going to show you in my demo. I've actually set up a 2-node cluster with Hyper-V, and I'm going to show you how I can fail one of the nodes over and watch the Hyper-V machine move over to the other node. And that's essentially what I want to show you. It's here where we talk about SMB. And SMB 3.0 provides lots of cool things. You can read through the bullet items that they now make available in Server 2012 R2 that allows us to do clustering using SMB shares. SMB 3.0 shares now can be used as our shared storage. So in your project, what I'm asking you to do is create a shared storage, a drive, a volume on one of your machines, and specifically your AD storage machine, and make that available as shared storage to your 2 host computers. Okay. In the demo I'm going to show you, I've actually got my disk drive set up a little bit differently. I'm not using SMB, but you'll get the idea. They talk about using the file server role, so we can share that out. And when we talk about file server role, that's the traditional role that we think of when it comes to having drive shares. I share a folder, I can make it then available to that machine, and other machines can access it as well. Well, we can replicate that. And one of the ways is deploying what they call a scale-out file server, which they talk about in 51. This type of file server can be used with a cluster, used within a cluster is called a scale-out file server, introduced in 2012, which is intended for application data such as Hyper-V or files that require reliability, manageability, and high performance. Okay, so let me see if I can give you an idea. I have a computer that is acting as a file server. I've shared a folder called data. And so my clients can go to that machine. That machine is called Machine A. They go to Machine A and they can access the data folder. Any of my clients can, any of the PCs in my network. They all store data, information out there in the data folder on Machine A. Machine A goes down. What happens to all my people who want to try to access that? It's gone. They can't access it. Why? Because the machine's down. Machine A is down. So what we can do is set up a scale-out file server so that Machine A and that data folder is set up in a cluster so that other machines, Machine B, Machine C, Machine D, are part of the scale-out file server, and they have a data folder on their machine as well that's available to them, or most likely it's shared storage. So that if the host that was hosting data, Machine A, goes down, I can still access the data as a client because I'm going through the cluster name to access it, and the data is actually on, it could be Machine B or Machine C that are hosting it now. Because of the failover clustering role and the scale-out file server, they've taken over control. So they're mentioning that in here. Different from a general use file server, the scale-out file server is an active failover where all file shares are online on all nodes simultaneously. And they replicate. So what I just explained would be kind of like a generic one. If one goes down, the others can host it. Well, in this case, they're all hosting it. And so I may be accessing the data folder that through the cluster, and I may be writing data to Machine A, where somebody else could be writing to Machine C, and it replicates the information in between them. So that's the idea of a scale-out file server. They talk about using Hyper-V over SMB3. Again, this is something you guys are going to have to be prepared to look at. They talk about VM monitoring, the ability to monitor the VM specifically with the idea of the resources that are being used within inside it. And again, this is something for the certification exam they expect you to be able to do. So you can monitor the VM. And you notice this chapter is what? Pretty short. Okay, there's only a few pages in here. But it is some pretty important concepts. So what I want to do now, and hopefully I haven't totally overwhelmed you with all these concepts and these things that are in these two chapters. Read through it, okay? Listen to this recording up to this point. Go back, reread the chapter if you need to, look at the PowerPoint, come back and then take a look at this demo that I'm going to show you. So I'm going to go ahead and access a machine remotely. And let me bring it back up. And I have 3 machines, very similar to what you have in your project. In your project, you've got machines called AD Storage, Host 1, and Host 2. Mine are Server 19, come on, Server 20, and 21. So Server 19, and I'll show you this quickly. I'm accessing this remotely. I'm going to log in with my codes. And by the way, I'm logging on as a user in the domain. So I'm logging on as the domain admin. So we'll log on to this guy. So this is my AD machine. This is Server 19. It's part of a domain called local.group70.cit.nmc.com. It's got multiple network cards in it. Okay. And this is one of my machines that's hosting my Active Directory. Let's take a look at one of my other computers. So let's take a look at 20. And I'll probably have to relog onto this one. 20, and I'm going to log on with the same account. So this is S20 or host 1. It's part of the domain. It has access to a NIC card. It's on the 192.168.70 network. Okay. And this one actually is using, has access to shared storage, and I'll talk about that in a second. Okay. So this is my second one. And the third one is Server 21. And if I go log onto this machine, we will see that it also is just a machine, host 2 it's called, and it's a node in my cluster. You can even see it tells you it's a cluster node. Okay? It's joined to the domain, and it has multiple IP addresses, which it's not displaying them all, and it has access to storage as well. So I'm going to go back to 20 and we'll start with that one. So in order to make this, all of this, come on, whoops, wrong way, place. There you go. So what I did for both of these two machines is installed the feature called failover clustering. So if we go up here and look at manage and add roles and features, and I'm going to go ahead and move this up. We'll hit next, next, next. If it'll let me to, come on. Oh, it wants me to select a machine. Thank you. It actually sees both machines. This is the roles. The next screen is the features, and we'll see that failover clustering is installed. Okay. What other things were installed on this machine? So on my host computers, I have failover clustering because I wanted to make host 1 and host 2, or server 20 and 21, part of a cluster. I've also installed Hyper-V. And this is what you're going to kind of do in your project. Your project, you need to take your 2 host machines, install Hyper-V, as well as install the feature called failover clustering. Okay. So if I go up here to tools, we should see in fact that failover clustering is there and Hyper-V is here. Okay. And if we went out to server 21, you'd find that it's identical. Not only is it the same configuration, but as far as memory and disk space and all of that's concerned, but I've also installed both of those, the role for Hyper-V as well as the feature for failover clustering. So once you get your host machine set up, the next piece that you have to do is you actually have to create the cluster. So I've already done that. In this particular situation, I've already gone through and created a cluster. So let's take a look at it. So I'm going to open failover clustering, and we can see that I have a cluster that I called Group 70. That was the name I gave it. And at the time, what I did is, when you first go into this, this is going to be empty. You have to validate, create a cluster, and then you can connect to it. These are the steps that you want to go through. And they talk about validation in Chapter 2. But what a validation does is you essentially tell it, hey, I want to create a cluster, so these are the 2 physical machines or 2 machines I'm going to use. It looks at the information on both of them to make sure that they both have the feature installed. You tell them essentially what you want to cluster, and it goes through a series of steps and checks. Do they have enough memory? Do they have enough disk space? Do they have the right features and roles installed? And it looks at both of them to make sure that there's connectivity between them, that they could establish a heartbeat, that there is a network between them. And it will then give you a report. As long as the report doesn't error out, you can create the cluster. It is important that both machines be at the same version of the OS, same service pack. So your host 1 and host 2 should be that way for your project. Okay, they should be at the same level, and you should be able to get through the validate configuration. And it takes a little bit of time. Depending on the situation, it can take 5-10 minutes to do that. Once the validation has been completed, then you can go on to the second option, which is create the cluster. You won't be able to create the cluster until you get through the validation piece. Once the cluster is created, then you can connect to it. Okay, so I've already done those pieces. I already have an established cluster in this environment. So I'm kind of jumping ahead to show you the end result. This is where you need to get to. But essentially, I have a failover cluster. Now, once the cluster is created, then we can work with these other areas inside it. Once you've connected to it, and again, you have to be logged on as a domain account. So, Chapter 3 talked about managing failover clustering roles. Well, what do you want to cluster? I happen to do Hyper-V. I said I want to manage and cluster Hyper-V. Now, if you take a look, you can, and I don't know if I want to go through configure role, but let's see what it's got here. This wizard configures high availability for a role. After you successfully complete the wizard, if a clustered server fails while running the role, another clustered server automatically takes it. So let's go to next and look at all the different things. These were the pieces that were discussed in here on page, it's one of the first pages at the bottom of 47. I can have a DHCP server that I can cluster. I can have a file server. I can do Hyper-V. Okay, I can do an iSCSI target server. I've already set up my role, which is Hyper-V, not the replica broker, but virtualization. And let's see if we scroll down through the list. Yeah, virtual machine. That's what I chose to use. So this has already been done. So I'm going to cancel this. So I went through and set up the role virtual machine as a clustered role. And I went ahead and created a virtual machine. And I'll show you, talk about this a little bit more in a minute. So my role that I've set up is Hyper-V. The role you're going to do for your project is Hyper-V or virtual machine. You can see that it says I have a virtual machine called VM exclamation point. It's running. It's a virtual machine. It's running on who? Server 20, host 1. So right now, this virtual machine is running on server 20. Okay. Nodes. Remember, we can have up to 64 nodes in the cluster. I have 2. 20 and 21, and it sees they're both up. And remember we talked about quorums. Each member has a vote. Each one of these guys has a vote, meaning that right now they're both up and running. If server 21 was down, the assigned vote would be 0. Storage. Okay. Manage disk and storage pools. Clustered disk can be added to the clustered shared volume or assigned exclusively to a clustered role. Now, the clustered shared volume makes it so that I can have multiple machines access that disk space so that if one machine fails, another one can access it. But they can do it concurrently. It doesn't have to be that way. But you notice it says clustered disk can be added to the clustered shared volume or assigned exclusively to a clustered node. In other words, you can assign a disk specifically to one node versus another. Okay? So let's expand this. Disk pools. So before I show you this, let's talk a little bit about my shared storage environment. So I want to take a moment and go out here, and I think I have it set up on this one. And let's take a look at disk management. And let's take a look at this server. And let's see if I can move this guy over a little bit. So this is a server. It has its own hard drive. Okay? It actually has 6 drives in it, 7 drives in it. Now, physical drives. But I'm using RAID. So I made those 7 physical drives in this machine. I set them up as a RAID 5 storage array. So it looked like one disk, and I partitioned it. So I actually have available to me about 1.6 terabytes of storage available physically inside server 20 that I've set up as a RAID configuration. And so the way the operating system sees it is it sees it as one big large disk drive. And I partitioned it and created a C drive and a D drive essentially. So my C drive, where the operating system is about 278 gig, and my D drive is the rest of it. So this is the local attached storage that's inside that computer. Now, you notice it says disk 2 offline, disk 3 offline. Okay? Scroll this over a little bit. Disk 4, disk 5, 6, 7, 8. Why so many? Because this computer is equipped and set up to see storage that I have created in iSCSI as well as fiber channel. This computer is a little unique. It has access to two different storage area networks. I have an iSCSI network and I have a fiber channel network. I'm going to go back for a moment and look at Server Manager. Under Server Manager, you can look at the file and storage solutions. Let's just take a look at the disks. Here's Server 20, and it says, hey, I've got 9 disk drives available to me. So I already told you disk 0 and 1 are the internal storage that this machine has. They're set up with RAID. But then this machine has 3 other disk drives that are set up for iSCSI. A 230 gigabyte drive, a 154 gigabyte drive, and another 154 gigabyte drive. And then it has available to it, sorry about that, several fiber channel drives. 154, 230, 181, and a 154. So it's got a bunch of drives that are available to this thing, all because of shared storage. Now if you're saying, well, how did you set that up? How did you access it? I'm going to talk about that when we get to chapter 6. I'll spend the entire video going through and showing you how I set up shared storage and how I set this up. All you need to know right now is I have shared storage available, and I'm actually using one of these drives as my clustered shared volume. So if we go back to the failover clustering manager, looks like I got it open twice. So let's go back just to one of these. I don't need it twice. And we look at storage. We will see that I have configured 2 disks. So cluster disk 2 is disk 6. So if we went back and looked at that list, disk 6 is the one I'm using as my shared storage for the cluster. And I added it as a clustered shared volume. You notice I can go in here and add another disk. So I could add as many of those disk drives as I wanted to the cluster. And then once they're added, you can right click on them and you can make them part of a clustered shared volume. Now I've already did that, so that's the reason they're showing up. And it says, hey, you want to remove it? So if I wanted to, I could say, okay, let's add another disk to this cluster. I could go through and pick one of the disks that are available, select the disk you want to use, disk 7, add it. The only reason it sees disk 7 and not the others is because they're offline. And then once it was added, it would show up back here, and I could right click on it and add it to my clustered shared volume. Now, because it is part of a clustered shared volume, this means that this machine and host 2, server 21, can both write to it at the same time. Well, where's the path to it? Look right down here. It's on my C drive. C: cluster storage volume 1. So if we actually go out and look at my C drive, you'll see that there's a folder called clustered storage volume 1. Oh, look at this. VM. Okay, VM exclamation point is the one that's running. There's where my virtual machine is running. There's my virtual machine's hard drive file. It's stored in the cluster. Okay? So it thinks of it as a local folder, but it's really what? It's shared storage out there that both of the machines can access. Alright, if you go back and look at chapter 2, we talked about disk quorums. Because I have 2 nodes, I had to configure one of the volumes or one drive to be a disk witness. So I went through and created, and notice it's not very big. How big? 1000 gig. Okay? And it's, look how much it's using. 946 megabyte of that gig is free. It's not hardly using anything. So I took and created took one of my disks, formatted it, set it up as 1 gig in size. So this should be something you want to write down and know. When you set up your project 1 and you set up your SMB share, you're going to need to set up a disk witness. So when you set up your disk drive for your SMB share on your AD storage machine, I suggest you create two disks. One that you can use to hold some data, one that you can use, and it's got to be at least I think 10 gig, and one of them is a small drive, a gig or less, for your disk witness. So you want to add a disk in here for the disk witness. Okay. I'm not doing anything with storage pools. Okay, not in this lab. All I did was set up my disks. Now, you are going to be a little bit different because you're using an SMB. You may find that you need to create a disk pool first. Okay, and you can actually do that on the AD storage machine. My networks. I have two. One says cluster network 1. Look at this IP address. 192.168.210.0. Okay, so let me tell you something. You probably are looking at it going, I don't know what that is. That's my network to gain access to my iSCSI shared storage. So I'll quickly talk about that here. iSCSI is shared storage over a network where you use dedicated network cards to connect to a storage area network. You assign IP addresses to those cards. So if you were to look at my machine at server 20 and server 21, I have network cards in there that connect directly to my iSCSI storage area network. I will show you this when we get to, I think it's chapter 6. And so they have IP addresses. So this is my disk network. If you think about it, and I said this in the very beginning, you have several different networks. You have a network for the nodes to be able to communicate with each other. You have a network for the hosts and the clients to be able to see the cluster. And you have a storage network. This is my storage network. Cluster network 2. This is the actual network that the cluster talks on. Now, in a true production environment, I would have more than these two. Why? I would have a network just for the cluster nodes, just for server 20 and 21 to see each other, and a separate public network for my PCs out there on my network so they can access the cluster resources. So what I'm saying is, remember we talked about a heartbeat? I would have a network set up just for the heartbeat, so server 20 and 21 could just sit there and talk to each other all day. And it's that heartbeat network that's going to be used if one of the machines fails and it needs to fail over the rolls. That's the network it's going to use. For this situation, didn't want to set one up. I'm using the production network, the same one the PCs use to access resources, as my heartbeat network. You can do the same thing. You don't have to have, 3 and 4 network cards. If you take a look at the way your project's configured, your hosts have 2 NICs in them. Okay? 2 network cards. They both can be used and talk on the same network, the same IP range. You don't have shared storage from the standpoint of iSCSI. Your storage area network is on your production network. And again, in a true enterprise environment, you would not do that. But for what you guys are going to do, it's fine. Okay? So I have 2 separate networks here. One for shared storage, one for all my cluster events, as well as the clients for accessing. All right, so this is the failover clustering role. Okay? Now, what else did I install on this machine besides failover clustering? See if you can remember. Anyone? Anyone? How about what? Hyper-V. We installed the Hyper-V role. So if I minimize my cluster and look, get rid of the disk management. We'll scroll down the bottom. Oh, I didn't open it up. Okay, so let's do that. I will go back up to the top. Tools. Hyper-V Manager. Well, test VM1. Huh? They're running. Well, that's a little strange. Let's go back and look at something. I'm on 20. Test in VM1. Well, let's go back to failover clustering. Let's look at my roles. VM exclamation point. 20. Well, what gives? Why don't I see test? Why don't I see VM1? Okay, so here's something that's a little confusing. When you want to set up Hyper-V in a failover cluster, you actually have to install the Hyper-V role, but you don't manage the VMs there. Let me repeat that. You set up and install the Hyper-V role on your host 1 and host 2, but you don't manage the VMs there. Any VM that you want to be managed by the cluster actually gets done right here. You'll notice that I'm on roles, and look what I can do. Virtual machine, new. I can actually create a new virtual machine inside Failover Cluster Manager. I'm not doing it in Hyper-V. So anything that you want to be part of the cluster has to happen inside Failover Cluster Manager. This VM exclamation point is running on server 20 as part of the cluster. But if you notice, when we went out to Hyper-V, we didn't see it. I can totally control this VM from here. I can save it. I can shut it down. I can change its configuration. In fact, if we were to look at the settings for it, okay, we would see that the disk drive, the disk folder for this is stored where? VM1. It's stored on the cluster volume. Okay, so it knows it's out there. It's on my shared storage. So when you want to set up your virtual machine in your failover cluster, don't do it through Hyper-V Manager. Do it through the cluster. This is where you manage it. Let's jump over to server 21 for a second. We haven't spent much time talking about this one. I'll log on, and again I'm logging on with the administrator that's part of the domain. And most of the time you would probably set up a dedicated machine to do, or a dedicated user for this, for managing the cluster. If we were to look, we would see, again, part of a cluster node. It has failover cluster running on it and Hyper-V. What does Hyper-V think is running on this machine? Let's see. Nothing. So there's no virtual machines running on here. Okay. Can it see the cluster? Sure, it's part of it. It's a node. We can go in Failover Cluster Manager. There it is. We've connected to it. Let's look at the nodes. It sees them just like Server 20 did. What's it see for roles? Oh, there's that VM exclamation point. It says, yep, it's running. Where? Server 20. Remember, I'm on 21. So this is what I mean. It's kind of strange. You're running a virtual machine, but I don't see it in Hyper-V. No, you won't. When you tell failover clustering the role you want to use is virtual machine, you manage everything from in here. You still have to have the Hyper-V role installed, but you do everything through Failover Cluster Manager. And so if I look, I'm going to see the same thing. I'm going to see dis. Oh, look, dis 2 and 3. And watch this. I'm going to go out to the folder, C drive, clustered storage, volume 1. There's my VM exclamation point. So both machines have access to the same shared storage, and because it's a clustered shared volume, this is where it shows up. Hopefully this is all making some sense. You may have to go over this video a few times. If you have questions, I'll gladly help you. But understand, this is what you're going to be seeing. Okay? Now, I'm going to cancel this. All right, so where's the magic? So let's see if I can show you some stuff, because this is really the fun part. So I've gone back over to server 20. Let's say that I need to do some maintenance on this computer for whatever reason. I need to, I don't know, I need to reboot it. I need to take it down. Could somebody actually be in using this virtual machine, a client? Sure. That virtual machine, you know, we didn't define what this is doing, but it could be doing just about anything. It could be servicing DHCP, it could be running an application, a line of business application. I could have end users that are RDP'd into it, remote desktop. We really didn't say what that virtual machine VM exclamation point was really being used for. But obviously somebody's using it and accessing those resources. And that VM is currently being hosted on server 20. That's the machine that has the resources allocated. I need to bring server 20 down. Okay, so I want to do some maintenance. So the way I can do this is I'm going to right click on that VM, and notice I can connect to it just like you could in regular Hyper-V. I can save it, I can shut it down, I can turn it off, I can manage it, I can replicate it, which is something that we'll talk about a little bit later on in another chapter. But I can also move it. I can live migrate it or quick migrate it. Okay, so what's the difference? Let's talk about that for a second. Understanding Hyper-V and virtual machines in the context of a cluster. Okay? It talks about live migration, quick migration, and the moving of virtual machines. So let's go down here and look at this. Okay, with live migration, when you initiate live migration, the cluster copies the memory being used by the virtual machine from one node to another, so that when the transition to the other node actually takes place, the memory and state information is already in place for the virtual machine. The transition is usually fast enough that a client using the virtual machine does not lose the network connection. So in other words, if my clients are connected to VM exclamation point, they won't even know it happened. I'll move this thing from one node to another. It copies the contents of RAM over because both machines have access to shared storage. It just happens. Okay? The transition is usually fast enough that a client using virtual machine does not lose the connection. If you're using clustered shared volumes, live migration is almost instantaneous because no transfer of disk ownership is needed. It doesn't have to transfer the disks because both machines have access. A live migration can be used for planned maintenance, but not for an unplanned failover. So live migration is great if I got to do maintenance, but if I lose machine server 20 and it goes down, live migration isn't going to help you. Okay? You cannot use live migration to move multiple virtual machines simultaneously on a given server running Hyper-V. Only one live migration to or from can happen at a time. Quick migration. When you initiate a quick migration, the cluster copies the memory being used by the virtual machine to a disk in storage so that when the transition to another node actually takes place, the memory and state information needed by the virtual machine can quickly be read from the disk by that node that is taking ownership. A quick migration can be used for planned networks but not for unplanned failover. Okay? So that's not going to help you with unplanned failover either. Okay, it's again for planned maintenance. So either one of these can be used. The primary difference is that with the live migration, it copies the memory over, where in the quick migration, it copies it to disk so the other one can be read. Okay. Moving, you can actually move a machine. When you initiate a move, the cluster prepares to take the virtual machine offline by performing an action that you have specified in the cluster configuration. So in other words, I may say, hey, I need to move this to another machine, save the configuration, move the entire thing over to it so it's hosted there, and then turn it back on. Okay? Now, the problem with some of these is that there's potential for data loss. So you'd want to do a save shutdown. You wouldn't want to just turn it off. The settings you specify for the offline action does not affect live migration, quick migration, or unplanned failover. It affects only moving or taking the resources offline through the action. Alright, so this is primarily used for maintenance. Now I can tell you, if we go back to my configuration here, that if I turn off 20, you're going to see it would, if 20 suddenly died, went boom, somebody turned off the power, 21 would pick it up. What would happen is the heartbeat between the two machines would stop. 21 would recognize that 20 is no longer available, and it would pick up automatically and start and load the virtual machine, because it's stored on where? The clustered shared volume. It would fire up server 21 and run it. Is there potential for data loss when this happens? Yes. Okay, there is a potential for some data loss. Because why? 20 didn't shut down gracefully. It just crashed. So if 20 crashed, 21 would fire up and automatically load that virtual machine and start it up, but there is a potential for some data loss. Okay, so even in an active cluster where you've got the two machines, there is a potential for some data loss if a machine physically dies. Now I'm going to go ahead and do a live migration. I want to show you. So you're going to need to watch up here under information, and let me see if I can actually move this over a little bit. Watch up here under information, watch for the node, watch what happens. Okay, ready? And oh, remember, what do we see? We see it running here, right? Okay, VM exclamation point. And we also, what did we see in Hyper-V Manager? VM1. And actually, I think I may have this renamed wrong. One of these actually might be the same name. But let's try something, okay? So let's see. All right. So here we go. Right click. Watch. I'm going to move it. Live migrate. Now I can tell it to select a node. So if I had 7 nodes out there, I could say move it to node 6, or I can say best possible node. Since I only have 2, guess which one it's going to do? It's going to move to server 21. Ready? Watch up there. Boom. Live migrating. Done. What? Yes, it's done. This VM was moved to server 21. It's no longer running on this computer. Let's see what we have in Hyper-V Manager. Look. So the VM1 I had there, I had it renamed. So it was different, and I apologize for that. In one instance it says VM exclamation point, and then in Hyper-V it said VM1. It is the same virtual machine. They're not two separate things. So I apologize I should have set that up differently before I did this. It is the same machine. So we did see it running in Hyper-V Manager, it just had a different name. So okay, so it's gone. So let's go back over and look at server 21. It's probably going to make me relog in. Nope. Okay, so we can look at our roles. And look, there's my virtual machine, and it's running on 21. And if you remember correctly earlier, what happened when we went into Hyper-V? We didn't have anything running. It's there. It's there. It is running. So let's go through this again. Let's move it back. Okay. So I'll go back to server 20 again, just so I'm using the same machine, and I'm not going to do it through Hyper-V Manager. Like I said, we don't typically do anything in there. There's my failover cluster. It shows me my role, says VM exclamation point, and I could probably just rename this, and I probably should. But I'll just go ahead and say move it. Live migrate. Best possible node. Live migrating. Watch that guy. It's on 20. Let's go back over to 21. Ah, look at that. 21 says I don't have any virtual machines running on me anymore. Why? Because it moved it back over to 20. So I can sit here and move these machines between nodes all day long. Okay. Through the live migration or even doing a quick migration. It's often referred to as draining the machine. I'm draining it off one host and moving it to essentially another host. Okay, so let's have some fun. Let's see. Of course, demos never work the first time, right? But let's try something. I'm going to go here to server 20. Now, I could just go ahead and shut it down. What happens if I did a graceful shutdown on this computer? 20's hosting what? The VM. If I just did a normal shutdown, Windows is smart enough to go, hey, this guy's running resources, I'm going to move them over to the best node. And it would move it automatically. So after I shut this, as part of shutting this down, we'd be able to go to server 21 and see what? That it, in fact, went ahead and moved it over. Okay? So, I hate to do this, but I'm going to. So what I'm going to do is go out here and I'm going to close Cluster Manager. I'm still in 20. I'm going to close all of my stuff. Remember that VM's running here, right? Okay. So one of the things I'm going to do is go out here through this guy. So what you're seeing here is all of my servers that I have running and available to me. If you listen to one of the other recordings, there may have been some reference to me getting some equipment, and I did. I received a grant, and actually here about a year ago I received close to $400,000 worth of equipment or money that I bought, storage area networks, clusters, servers, all that stuff. Okay. So I have 22 file servers all set up here, and to give you a little bit of information, they're dual proc, 12 core each, 128 gig of RAM. Each server has access to 1.6 terabytes of data or 1.8 terabytes of data. I've got 2 storage area networks, iSCSI and Fiber Channel, each with about 8.4 terabytes of data, all the switching gear, everything. I got really lucky. And so that's what I'm able to demonstrate and do some of the stuff with. So, server 20. Okay, so this is where it's going to be fun. I'm going to go up here to my service appliance. And what you're seeing is my KVM. This KVM is what I can use to manage and turn on all these servers. So I'm going to go in here to find the right one. I want to locate server 20. There it is. So server 20 is on port 38. Okay? And I'll talk about the iDRAC later. But what I'm going to actually do, and let's watch this thing. Here we go. Power. I'm just going to turn it off. We're going to simulate a power failure on one of the nodes in our cluster. So I'm going to take this guy and go, boom. That machine just went off. Let's take a look. This one, 19's still on. It just happens to time out. Don't scare me like that. Let's see. It should come up. Yeah, 19's on. What about 20? Nothing. 20 died. We powered it off. Hard failure. What happened to that VM? Well, if my demo works, let's go find out. Look at that. Now, oh, look at that. It moved it over. So 21 said, hey, the VM's not running. I lost my heartbeat. I better start this virtual machine up. So it is now running that VM. And if we go out here and look at nodes, what's it know about my node? 20's down. Says it's draining. In other words, it essentially brought that role over onto 21. Cluster says, hey, I got a problem. Why? Because we can go into cluster events and take a look at the event. And it should show us that there was a failure on one of the machines. Yeah, it's got an error on S21 with a resource. But essentially, cluster resource virtual machine VM exclamation of type in cluster role VM failed error code. Okay, so essentially it lost its state on the other machine. But we should see that yes, it is running. In fact, it's there, and if I wanted to, I could in fact what? Connect to it. Hopefully. Come on. There it is. It's doing something. See if it'll let me do a control delete to log on. Yep, there it is. So that virtual machine is running. And what did I do? I simulated a power failure. Now, I can go back out here, turn 20 back on. And it's not going to happen instantaneously. This machine's got a lot of equipment in it, but we should see eventually here 20. Yeah, it's starting to boot this up. So it will boot up. It will reconnect to the cluster. Will it move the virtual machine back? No, not necessarily. What we would have to do is go into the actual virtual machine, and if we went into the properties of this, you would see that there is an item in here that says preferred owner. Select the preferred owner for this cluster role. Use the buttons to list them in order for the most preferred priority, and then what to do in the case of a failover. So we know that that virtual machine is preferred to be on 20. But if we could take a look in the failover piece, did I tell it to move it back? Specify the number of times the server will attempt to reset or refail over the cluster to the specified period. Allow fallback. So specified whether the cluster role will automatically fall back to the most preferred owner, which is on the set of the general tab. Yeah, so it should eventually, when 20 comes up, go back and move from 21 back to 20 because of the way I have this virtual machine configured. So you notice I do everything in where? Failover Manager. And by the way, once the other machine is up, the node should show that it's coming up. It's not there now. Why? Because it's still in the process of what? Booting. You can see it's connecting. It's finding disk drives. Emulex happens to be the fiber channel card that's in this machine. But it is coming up. So eventually this will show it's connected, and it should move that VM over. If not, I can live migrate it myself. Now it will always have this red thing in here, this X, to let me know that there was a problem. I can actually, in fact, if we go to Failover Cluster Manager, you'll see that it says 1 down of the 2 total. I will be able to go in here and right click and reset the events. So it's reset. Does that mean it's active? No, I still have something down, but I at least reset it. Okay. If I wanted to add another node, I can do it here. Okay, copy the roles. Cluster aware updating. Again, I had to install this, but essentially cluster aware updating, as I mentioned earlier, allows me to do what? Schedule Windows updates. Now, I can do it from within cluster failover clustering, or if I scroll down to the bottom, I think I still have Server Manager open. Under Tools, cluster aware updating is there. And essentially what it allows me to do is go in here, connect to a cluster, and then apply updates to the cluster, which then, if it saw multiple machines, would download them, install them on one, reboot it, or move the resources over, reboot it, and then start the process on the others. But I'm not going to connect to the cluster right now, and not while it's still trying to come back up and active. And let's see, we've already spent enough time. Look at this. It says, wait a minute, there's a problem. What's the problem? Refresh automatically failed. Probably going to come back and say that there's an issue with the cluster itself. So let's see where we're at. Maybe we're further than I thought we would be. 20 is in the process of still trying to come up. So hopefully this gives you an idea of how this whole thing works. Yours is going to operate very, very similar. You're going to install Hyper-V role on both host 1 and host 2. You're going to install the failover clustering role. You need to first set up AD storage. Okay, get AD installed, join both your host 1, host 2 machines to the domain, use the domain admin account to create and manage your cluster. I mean, those are some of the things. I'm not giving you every single step. You need to kind of figure some of this out. This is a third level server course, but at least should give you enough information to get you started. So I would take your AD storage machine, and the first thing I would do is set up Active Directory on it. Well, there's other things you got to do. If you look at Project 1, you got to give it names, you got to set up IP addresses, you got to do all that stuff. But as part of it, you want to get Active Directory up and running on it. Partition a disk big enough to hold a VM. And for your guys' concern, I don't even care if the VM's on and running. You can move a VM from one machine to another without it even being turned on. And you may find that disk space is an issue, especially with SkyTap. But you can still create a virtual machine and have it point to the disk on your clustered shared volume. But creating the VM should be the last thing you want to do. You need to get the cluster created and validated first. Okay. All right. So my machine's up. So let's quickly go back in here and see what we can do. So I'm going to tell it to log on. So 20 came up, and of course Windows is probably going to go, "What did you do to me?" Yeah, that's what I thought. I experienced a unforgiven, suddenly unknown problem. Oh, I lost my mouse and keyboard for the moment. It's going to take a little bit for my KVM to suddenly come back. Let's see if I can do some things here. Session options, mouse, enable, general, okay. In fact, sometimes what I find, folks, I will lose the keyboard. So I'm going to do this. I'm going to cancel out of this for a second. I'm going to close this virtual machine window. Let's go back to this guy. And I'm going to go to here. That was 20, right? And I'm going to open up the KVM session again and see if we can get my keyboard interaction running again. Yep. Do not like Java, but that's beside the point. There we go. Gotta wait for it to synchronize. Come on. There we go. Now let's see if my keyboard works. Still not working. Well, that's not good. Technology's fun when it works, folks. Pass out keyboard. Usually this takes care of it. Let's see if I can change it to a different option. Even the mouse isn't working. Let's try single cursor. There we go. There we go. Now we got a mouse. Let's see if we can type in here. Perfect. Okay. So now let's go back to the clustering. Because what happened? Oh, look, both nodes are back up. That's good. What about the roles? Look what it did. It moved it back. So, my machine, I fixed the problem, the hardware error, I brought it back up, and because of the preferred status, it automatically moved it back over. If we now go back and look at 21, Oops, I changed the order of them. Hang on. And we look at Hyper-V. We see nothing's running. Okay, so that's really the lecture. Again, I went over some of the concepts quickly. I realize, but I wanted to get into this demo and really show you some things. So for your project, take some of the information I've done here, pay attention to chapter 3 where they talk about SMB, look at some of the videos I put out there. Jose Barreto has got some great videos. There's some stuff from TechNet Radio where they talk about using Hyper-V over SMB, because that's essentially what you guys are doing. You don't have a storage area network like I have available to me. So we have to do the best we can, and that's where we're going to use an SMB 3.0 file share. But hopefully this gives you an idea of some of the abilities that we have. By creating this 2-node cluster, I can have a specific role, and in this case I'm using Hyper-V virtualization, and you can see that it moves from one machine to another. So please let me know if you have any questions. I apologize for this video being lengthy, but I wanted to take a moment and go through it. Did I cover every single option in here in failover clustering? Absolutely not. But I gave you enough to get in here and at least get your feet wet, which is, what you would start out doing at an enterprise level. If you have access to resources where you can do these kinds of things, I encourage you to do so. Play with it. The certification exams for this class, if you decide to take it, really you've got to be able to play with all these options, all these features, understand how you would apply them. As I said, this is one of the harder exams. Did I show you anything with regards to the PowerShell commands? No, I didn't, but they're there and available for you to use. I am, believe it or not, a big PowerShell guy. I like to use PowerShell. It's just in this environment, I want to, and this is for many of you, this is your first access or use of clustering. I just wanted to, get you familiar with stuff. But we should be able to do, look at the cluster information. Let me see if I can do one command really quick and see if it'll run it. Let's see if it will do a get dash cluster, and it may not like it. Yeah, you didn't have administrative privileges, so hang on. And why is that happening? Because yours truly didn't run PowerShell as an administrator. Let's try this again. Yes. So now let's see if we can do it. Yeah, so it knows the cluster name. And if we were to actually look, one last thing I'll show you, and then this video's been lengthy, and I apologize for that. But if I went back over to 19, remember this is my AD machine. This is also the machine that's running DNS. When I created the cluster using the failover cluster manager, after I validated it, I gave it a name. I called it Group 70, and then I also gave it an IP address. So here's S19. This is my Active Directory, Group 70. So my cluster is 192.168.70.100. That's the address I gave my cluster. In fact, we should be able to do things such as ping that. And it knows it's there. And that's actually the cluster. Okay? And so people could access that as a resource. If I did do the file server cluster role, I could have shares out there, and they could access group 70 / and the name of the file share, and not even know which machine it was connected to. Okay, so hopefully this helps. It gives you an idea. You can see I'm quite lengthy in my lecture, and I could go on and on and on. I really get into this stuff. So hopefully what I've showed you is enough information. I appreciate you listening. Let me know if you have any questions. Thank you much.